In this video, I will show you how to calculate the integral of the square root of 16 minus x squared dx. The first step we can do is I'm going to use substitution. I'm going to say that my x is going to be the 4 sine of u theta. I'm going to use theta. And my dx will be the derivative of 4. The times sine of x is 4 times cosine of theta times d theta. I'm going to replace the substitution is going to be square root of 16 minus 4 square sine square theta times 4 cosine of theta d theta. And this is the integral. If I factor out the 16, I have the 4, the square root of 16, 4 is out, and that's going to be 1 minus the sine square of theta times another 4 times the cosine of theta, this theta. Now 4 times 4 is 16. And then we have the integral of the square root of 1 minus sine square of theta times the cosine of theta, d theta. And now we have 16. 1 minus the cosine square of theta is the 1 minus sine square of theta is the cosine square of theta. Now we have cosine square of theta on the square root, is going to be the cosine of theta. And then the next step we're going to write is going to be 16 square root of the cosine. They cancel each other. Not exactly, but they cancel. This particular case, I'm going to have cosine of theta times the cosine of theta d theta. And I'm going to have the integral of 16. We delete this and put this 16 times the integral of the cosine square of theta d theta. Well, now the cosine square of theta, cosine square of theta can be written as cosine of 2 theta plus 1 divided by 2. And we'll replace 16 by the integral of the cosine of 2 theta plus 1 divided by 2 dx. 16 divided by 2 is going to be 8. I'm going to separate the two integrals. 8, the integral of the cosine of 2 theta plus 8, the integral of d theta, sorry. We delete this. 2 theta d theta plus 8 times the integral of 1 d theta. And then I'm going to use substitution. I'm going to use for calculating this one, u will be 2 theta, du is 2 d theta. I'm missing the 2 here. And then I'm going to divide by 2 here. And then the new integrals, the new integral is going to be 4 times the integral of cosine of u du plus the integral of 1 is d theta is 8 times theta plus c here. Now the integral of the cosine is the same. We're going to have 4 times sine of u plus A theta plus C. But we have to replace theta back. It's going to be 4 times cosine of 2 theta plus 2 theta plus A theta plus C. And now we're going to have the 2 theta plus C and times. Now we will write, sorry, so cosine is sine here. Is sine of 2 theta. Now, but the sine of 2 theta 4 times is going to be the sine of theta times the cosine of theta. It's going to be 2 times. We're going to put in red. 2 times sine of theta times cosine of theta plus A theta plus C. I'm going to have 8 sine of theta times cosine of theta plus A theta plus C. And then we will replace we're going to write that this is 8 times theta plus 8. I'm gonna write the sine of theta, but the cosine I'm gonna write everything in terms of sine, which is the 1 minus cosine square of the cosine of theta square root of 1 minus the sine square of theta plus C. And then I will have, but then I'm gonna go back to the original function. If x was equal in the beginning, the substitution was x4 sine of theta, 4 sine of theta. Then sine of theta equals x over 4, and theta equal the inverse function of the sine divided by x over 4. And now we're going to apply everything back. The answer here is going to be 8 times the sine, the inverse function of the sine of x over 4 plus 1/2 of the square root of 16 minus x squared, which is the cosine, times dx. The x that we have in the beginning, because it's gonna be 8 times x over 4, and then we're gonna have the 1/2 here. And this is the final answer.